we understood about IP, MAC address, and using both the information, both the addresses, how our devices do communication. Okay, that
Okay.
part we covered in the last class, but that was just a top level overview, not the starting of the CCNA actually. So today we are going to start from the very scratch. There will be seeing OSI model today. Not only today, even tomorrow also will be seeing OSI model. If the things will remain there, then also we are going to see at least 1 or 2 more days, because OSI model is something that is really, you can say, building block, or you can say this is base of networking. Yeah. So
Okay.
OSI model, what do you understand? What is OSI model? Do you have any earlier idea? If you want to share something, you can share. So accordingly, I'll be picking from the same location where you will left. Okay.
Okay. Uh,
Yeah. Go ahead.
so basically, I don't know uh, about OSI networking.
Okay. No issue at all. No issue at all. This is the right place where you are right now if you don't know. Okay. Because I'm going to help you to understand that. Fine.
Yes, yes,
So just simply I'm giving you one scenario. Just understand this, then you will be able to understand really OSI model. Correct?
yes,
So
yes.
let's suppose you started a company.
Hmm.
All right. You started a company and you manufacture a computer, just
Huh.
like HP, just like Apple, just like Dell, just like HCL. These are the companies who manufacture computers and many other things as well. I'm just talking about computers right now. So
Okay.
let's suppose Harshvardhan has started a company, and the company's main, or you can say core job is to manufacturing computer. Is that so far good, right? You are understanding
Yes,
you
yes, yes,
company and you manufacture computers. Okay.
yes.
Now, what computers Harshvardhan's company is manufacturing, that has very good thing. And what is that? That is, the company computer can talk with company computer only. What does that mean? Let's suppose Harshvardhan one laptop is made manufactured this day, that is Saturday, and tomorrow another computer got, or you can say laptop got manufactured. So both the laptop can talk with each other only. Once, so this is the restriction as well, and this is the good thing as well. No other company can talk with Harshvardhan's company manufactured laptop. Now, if this is the only case, like this is the restriction, only Harshvardhan's laptop can talk with each other. So after some time, once other people also start buying the laptop from Harshvardhan's company, they also will start seeing the same thing, like the laptop can only talk with the same company laptop. Now tell me, if this is the scenario, your company manufactured laptops can talk with only your company's manufactured another laptop. So is this a good thing or bad thing? What do you see?
It looks like a bug.
Just 1 minute. Huh? Kindly allow me a moment. Harshvardhan, just allow me a moment, okay?
Yes, yes, yes.
Yes, yeah, as you said, this is looks like a bug, right? Correct?
Yes, yes.
So, yeah, you're right. So only if one laptop company can talk with only the same company's laptops, it is not a good thing actually, isn't it? It is actually narrowing your network, isn't it?
Yes, yes.
It is not allowing your company laptop is going to connect. Let's suppose another day at your home, your friend visited and he has a laptop that is HP laptop. Now he wants to take some data from Harshvardhan's company laptop. So what will happen then in that case? That they don't connect, right? Why?
Yes, yes. My company laptop is different.
Yeah, different, and it doesn't allow someone else's to be connected with the same laptop. Yeah. So
Yes, yes.
so this is actually early days. Like once Harshvardhan started manufacturing these laptops, Harshvardhan was thinking, yeah, this will give us a unique identity in the market, right? But this was not the case. So what
Yes.
happened? This was the case in early days in networking as well. Harshvardhan. Hi Mohammed. Okay. What was the case? Once the manufacturing companies started manufacturing devices, computer devices, what happened? They were not interoperable with each other. Like HP was only able to talk with HP, HCL was only talk with HCL, IBM was only talk with the IBM. So this was the issue actually. What was the issue? Like the same company devices were able to talk with each other easily. But once it was coming to talking with another company device, they were not compatible actually. This was the case in early days. Are you with me so far understanding?
Yes, yes.
So to solve this issue, ISO is one organization who comes up with the solution. That was OSI model actually. And what OSI model does in that case? OSI model is not any practical model actually, but this is a reference model. Reference model means what? Let's suppose uh, before making a building, what you do actually? You automatically start making the building, or you need some sketch, or you need some blueprint, or you can say, yeah, definitely some design of the building. Definitely answer is design of the building first, right?
Yes.
So what they did, so OSI model is actually a reference model, that is like a blueprint, or you can say design, how network should behave. This is all about that. And all the networking things are divided into 7 layers inside the SI model. And what happens once SI model is in the picture, all the manufacturing companies started making their devices, manufacturing their devices by taking care for all the SI model layered approach. Okay.
Okay,
And
okay.
once this comes in the picture, all the company users, all the company manufactured devices were able to talk with each other. And this was the solution actually. Yeah. So
Okay.
this is the story how your SI model comes in the picture. I hope you are understanding. Hi Mohammed. You joined little bit late, but I think we
Yeah,
were not very good. So
yeah,
you
I
got the
have joined late. Yeah, sorry.
no issue, Mohammed. That's fine. That's fine. So
Yeah,
what we are talking here actually, we are talking about OSI model. Okay. So
yeah.
the today's topic is OSI model.
Okay.
So what we have discussed so far, nothing actually. Are you are not able to see my screen? Now I'm just talking, not shared anything
Yeah,
so
yeah.
far.
No
So
worry.
any idea about OSI model, Mohammed?
Yeah, yeah. It has 7 layers, which is used to communicate with each other to the between the devices.
Mm-hmm.
Yeah,
Good. Okay, that's fine. You are going good. So just allow me a moment. Let me share my screen. Then I'm going to show you other wonderful parts, guys. Okay. My screen is through, right? You guys are able to see the screen, correct?
Yes.
Yes, 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 yes.
Just let me make it bigger if it is allowing me to make it bigger. Yeah, I don't see. OSI model, okay. What is the full form? Open. Now see, now full form is even saying open system interconnection. Getting it? So Harshvardhan, now you are able to relate. It is saying open system interconnection.
Yes, yes.
So the purpose is by itself, its full form is saying, right? What was the purpose of OSI model? It was there so that all other companies can be connected, interconnected with each other once it comes to networking. Yeah. See, open
Yes.
system interconnection is the full form actually, and uh, is the full form of OSI. This is a model that is used as reference. If the screen is good, then that is okay. Like font is fine, right?
Yes, yes. Font is fine.
Okay. Just one moment, please. Let me take a cup of water only. That after that I'm going to start. Yeah. Just allow me a moment, please. Okay, I'm back. Okay. So this is a model that is used as a reference, or we can say blueprint. It has 7 layers. Like I am just putting little bit details that I want share with you. Otherwise, there on internet so many details about the SI model. You can easily Google it. Okay. But the main thing that I need actually that I'm putting here. Is that fine? Like I'm not
Yes, yes,
giving you
yes.
complete theory type thing, right? This is not, I think this is not you are expecting from me to give all the theory only. The main thing I am giving, if you need more about this, then kindly go on Google it. Okay?
Yes, yes.
You get more than whatever I'm giving. Yeah, really. So it has 7 layers, and there are specific layers and layer names. First, like this is the application layer, let's suppose. We call this as layer 7. And after that, we have layer 6. It is presentation layer. Is this presentation? Yeah, if you anyone remember. Like once you will be giving interview, guys. So first of all, the interviewer will ask you these 7 layers name. Believe me. Like first time, very fresher level. If you start giving, na, then they are going to ask you tell me all the 7 layers name of OSI model. Then you will be saying, oh man, I don't remember that. How can I tell now? So so make sure you remember this, yeah.
Yes, sir.
Layer 4 is transport layer. Layer 3 is network layer. Layer 2 is data link layer. And layer 1, this is physical layer. Okay, guys. Simple, right? Yeah.
Yeah.
So once we actually start talking with another device in the network, so these layers are involved during that communication. Actually, in backend, there are so many things that is happening, and those things are happening somewhere inside these layers. Okay. Let's talk about cable, for example. So if your laptop is connected with internet, either using cable or using some wireless communication, isn't like wireless medium. Right now, if you guys are talking with phone, you connected using phone, so your communication mode will be wireless, right?
Yes,
Isn't
yes.
it? And if you are, let's suppose you joined using your laptop or like old time desktop, most probably you have connected LAN wire behind and you are connected using wired mode. You can say wired media. Agree. So these wireless, they both work at OSI model's physical layer. Is that good? You guys are able to relate?
Yes.
Yeah.
Your cabling, your wired, your wireless, they all work at physical layer. Simple. Okay. Okay. In your laptop, whatever media like wireless or wired you connected with internet or connected with network, that certainly will have MAC address. If you remember last class, I told about MAC address. Okay. Not in very detail. Everything will be same further. But MAC address is a address that already will be there once you are purchasing some new device, and whatever network interface cards you have installed in that device, that much of MAC addresses you will see inside your device. Is that good? Able to relate? Let's suppose if you're not able to relate, I'm sharing my screen and I'm showing you that. Just wait. Oops, not done, guys. It was removed. Just one moment. Don't worry, I'll be explaining if you don't know that. So right now, how many of you are joined using your laptop? Tell me. Anyone?
No, I have joined through mobile.
Yes, yes. I will join through laptop.
Okay. Okay. Can you run a command in your laptop, please? Windows laptop or MacBook? What is
No.
Windows?
Windows I have.
Yeah. So just do one thing. No, don't do anything. Let me do. Just do it. See, is this a screen through?
Yes.
This is a PC. I just bring it in the workspace. I'm clicking on it and going inside config. See my cursor. Are you able to see fast Ethernet 0 and Bluetooth?
No.
Just okay, thank you. Just allow me a moment. Let me share. Might be because not shared the complete screen. It happens. Wait, let me share the complete desktop. Then it will be going good. Now able to see this PC and after that this particular window. Tell me.
Yes. Now it's visible.
Now see, it has interface. Now I was talking about this interface. You have fast Ethernet 0. There you can connect cables, right? You have Bluetooth. Now see clearly. Are you able to see this MAC address?
Yeah.
In Bluetooth, are you able to see this MAC address? This is hidden actually, but you are able to see. See,
Yes, yes.
right? Na? Now you are able to relate, I hope. So as much
Okay.
as you have network interface cards installed inside your laptop or device, that much of MAC address you can see. Bluetooth, fast Ethernet. Let's suppose you have some wireless NIC also installed. So if that is there, then you are going to see another MAC address and another interface also here, wireless type thing. Able to relate? Yes, no?
Yes. Yes. Yes.
Simple, yeah? Yeah, simple really. So if you say even I can show you if I go in physical, na? Just wait. If I can show you. I don't know it will give me or not, but it is turning on. This is PC or this is lab old one. Let me see. Laptop might be working. Yes. Now able to see this lap. This is laptop. See, this is
Yes.
Ethernet. Okay.
Okay. Yes.
Let me turn it off. Once I'm clicking here, it is turning off. If I can remove, I can remove this. If right now you will go inside your config, na, just let me turn it on. It is saying it is not on. Fast Ethernet, same thing. You have MAC address. Bluetooth, you have MAC address. Right? Yeah. I'm coming in the physical one. I'm turning it off and I want to connect one wireless port with this. This one. It is here, right? Wireless I connect. Now I'm putting it turn on. Now go to config. You are able to see wireless now. See? And it has another MAC address. Getting it?
Yeah. Yeah, yeah.
This is similar type of thing that I was telling. So cables. Let me actually make a topology, na, then you will understand really. This will be really good. So I am just taking a device here. This is switch that we used in the last class actually.
So every communication required MAC address. It can be a virtual or the hardware, correct?
Definitely. MAC address is actually, na, who asked? Harshvardhan.
Yes. 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 I asked.
So yeah, Harshvardhan, what happens once you are purchasing any device, na? So whatever device you are purchasing, give me a moment. I'm getting a call. Yes. So what I was saying, Harshvardhan, I was saying, are you there, right? Yeah, you are.
Yes, yes.
So once you are purchasing any new device, so the device will have some NICs pre-installed. NIC means what? NIC means that port that you connect so that you can connect with internet, you can connect with another PC, you can connect with printer, all those ports, right? Like
Yes,
ports, I'm saying ports that
yes, yes.
you'll be using for communication, or you can say you'll be using for connecting with the network. Those ports by default will have hard coded MAC address already. Like it will be coming with the MAC address. You don't need to do anything. So
Okay. So
this,
every port will have a different MAC address, or
yes, yes, every port will have different MAC address. Not only that, even the MAC address you are seeing in your laptop's port, that is universally unique actually.
okay,
Not only every port will have different MAC address, even all over the world, whatever MAC addresses are available, they all are unique. Correct. And if you are bringing some new device, even in the ports MAC address section, if you see, every MAC address is unique. No MAC address is duplicated.
okay,
Okay.
okay.
I
So
hope it's. Mhm, yeah.
in the virtual machine, we get the MAC address. That's a different MAC address, or it is same MAC address?
Same MAC address actually.
Okay,
These devices are there to just demonstrate the device, na real device, isn't it?
okay,
So the MAC addresses are still they are unique. Let me show. Let me show you. Why? See how actually these MAC addresses are unique. This can be a question, right? So let me
yes,
tell you. Actually, there is a company. That company name is IEEE. Okay, there is a company name IEEE. Not company. You can simply say this is institute. Institute of Electrical and Electronics Engineers. Okay. So
okay,
what they do, this company is responsible for MAC addressing and all those. So what they do actually, so MAC address in itself, let me tell you, MAC address is an identity of 48 bits. Getting it? 48 bits. Starting 24 bits are reserved, or you can say bits are OUI bits. OUI bits means these bits companies purchase for assigning MAC addresses to their manufactured devices. Getting it?
yes,
So OUI means what? Let's suppose you are a company. Just we took example like Harshvardhan's company. So once Harshvardhan will start making devices and you will start manufacturing the devices. So whatever NIC card will be there inside your device, you are going to IEEE and you will ask, hey, my company name is this. Can you give me one series of OUI to me? So that IEEE will provide you that. Once you are coming with that OUI, then last for 24 bits, companies can use last. See, starting 24 bits you are getting from IEEE. Okay. Now 48 bits is the total identity. 24 bits who will provide IEEE, and last 24 bits companies can use for assigning the MAC addresses. Okay.
okay. So 24 bits of OUI assigned by IEE to the company would be unique, and after that 24 bit would be variable.
Yes, that vary to the company, and company now will make sure that is unique. Correct?
Yes, yes, yes. Okay,
So in this way, throughout the world, all the MAC addresses are unique actually.
okay.
Okay. So let me take an example. Very simple example I'm taking. Just see here. So let's suppose I am going here, clicking on this PC, then config. It's turned off. Let me turn it on. Config. Then I'm going on fast Ethernet 0. Let me see it. Now see how many bits are these? Tell me. Any guess? If you'll be counting, this is only 12, right? But how it comes to 48 bits then? So now clearly it is showing us this is not in binary. This is in hexadecimal, isn't it? So hexadecimal means what? One hex digit equal to 4 binary bits. Now this is how many? 12. 12 into 4 into 4 equal to 48, right? In this way, this is become.
How do I detect it's hexa or binary?
Yeah, I'll be telling you.
Okay,
Today only, don't worry. Like this OSI model is going to be a very big class actually. Not today, tomorrow, after that, two, 4 classes more. We'll be seeing only on the OSI model and we'll be trying to understand complete thing. Okay.
okay,
MAC addresses, IP addresses. Once the subnetting will come in the picture, then we also will see the subnetting. Okay. So
okay,
this is not a like of I'm not here to actually let me tell you my agenda. So guys, I'll be not telling you the just the concept only and will be moving ahead. No, I'll be saying you the concept, will be connecting those concepts with each other, connecting the back dots with each other, and let it make a complete sense. Okay. So this is my agenda actually in this training. So I'll be not just going, this is OSI model, these are the layers, that's it. Okay, done. Let's move ahead. No, not like that. You will be getting complete sense once you finish with the CCNA complete training. Okay, everything will be interconnected with each other.
okay.
So just wait. Let me first of all let me show you the OUI actually. Na? I just copied this 48 bits identity and I am going on internet and wait. Chat GPT will be good, na? Tell me about this MAC address. Now see what it is saying. This is the given MAC, na? Now see. Organizationally unique identifier is the starting 12, starting 6, not 12, starting 6 one. 6 hexadigits, right? This is 24 bits. Okay.
Binary.
Yes.
Okay.
Manufacturer vendor, this is giving in the Hindi. Make it in English. Sorry, guys. Okay. Chat GP starts doing experiments in the way. See, first 24 bits of the MAC address identifies the manufacturer vendor. So in the provided MAC address, I provided this MAC address. This starting one is what? OUI vendor, right? IEEE. Making sense? Who provided that? IEEE. Now, rest one is to the NIC identifier or you can say device. Like this, your manufacturer will use to assign the MAC addresses.
Okay.
So tell me about the company name who got this MAC address. Just 1 second. If it is not giving, I'll be going directly in the MAC address lookup. Just wait. Now see, who is the owner of this 00D097, guys? Answer you are getting? Company name is 3Com Corporation.
Okay. This is a public information, correct?
Yeah, this is public information. Isn't really this is public information. Correct.
Okay.
So now this is the very good thing that you are coming to know who manufacture all the NICs for Cisco. So answer is 3Com. 3Com is a company who actually provides all the NICs to Cisco. See, this MAC address also belong to 3Com. Able to see?
It is like IPv4.
This one? No, no, not like IPv4. IPv4 is something different.
Okay.
MAC addresses are hard coded inside the NIC. Okay. But
Okay.
if you are saying IPv4 like IP address, they are not hard coded. They are logical. They can vary. They are
Okay.
variable. Okay. So
Okay.
let's suppose you are right now at home and connected with Wi-Fi at home, you will be getting another IP address.
Hmm.
Once you are approaching office and you connected your office internet, you will be getting another IP address. Correct. So
Okay.
in the different places, you are going to get different IP addresses, but MAC address always will remain same. That is not going to be changed. Okay. So MAC
Okay.
addresses are different, IP addresses are different, and the purpose of these devices are also different. Okay.
Okay.
Yes. Getting it, na guys?
Yes. Yes.
If the question is there, that is very good thing. Hi Akram.
Hello, sir.
Sorry for always interruption, guys. Today, actually, so many calls I'm getting in morning. So I will say thank you so much for your consideration, everyone. Okay. Hi Akram. So is this your first day?
Yes, sir.
Okay, no issue. So you are getting now what we are talking here, like MAC address, very
Yeah.
basic things we are talking so far. Not anything we have went little bit advanced one. No, very basic one. So just be here and relate yourself with the concept. Okay,
Sure,
you'll
sir.
be getting it. Yeah. So point is we were talking about MAC addresses. So MAC addresses are actually physical address we say, and that will be hard coded with your devices, not the logical one. These are the physical one, guys. Okay, Harshvardhan.
Okay. Okay.
So just we not need to compare this with the IP. Actually, IP is something different. That is also important address. Okay. And MAC addresses are also different, and they are also some type of address that has some different purpose, and IP address has some different purpose. That will altogether will be talking ahead, not right now. Okay, good.
Okay.
So if I'm giving you one MAC address and I'm asking you, tell me who is the owner of this NIC, then you simply can see the starting this one. Which one? Starting 6 digits, hex digits, and you will come with the conclusion. Understood? You just need these starting 6 digit. 6 means 24 bits, right? 24 bits if you are getting, you'll automatically will be able to identify who is the owner of this particular MAC address. Getting it?
Okay. Okay.
Yeah. And the last one, it varies. So far, so good. Correct?
Yes.
So
Yes.
let's jump to this. Mhm. So, okay. Let me connect all the devices with each other to make it a complete sense. Then I'll be just lending all the things to the SI model. Okay, just wait. So here we have PCs. Let me take many more. This is okay. connected these devices with each other. Okay. Yeah. I'm going and giving an IP. Giving an IP. Is that fine? So just to demonstrate you the purpose. /8. I'm giving here 10.1.1.2/8. I am giving here 10.1.1.3/8. Might we all be wondering what is /8? What is this IP all about? No need to wonder. I'll be telling you everything from basic, means from zero. Correct? If you don't have any knowledge, don't worry. You are at the right place. I'll be telling you everything from scratch. So just to demonstrate this, I'm just giving IP. So this IP, if you don't know, let me tell you, IP is actually identification of these devices in the network. Is that fine? This is unique identity that you are giving to your device. So your device will be known from this particular IP inside the network. Let's suppose if
Okay.
this is a network. Okay. If this is a network, then your device will be identified by this IP that you just gave. Able to relate? Yes?
Sir, one query I have. So,
Hmm.
this is a private IP that you are assigning. So,
Yes.
on the network level, does uh, firewall can identify which from which private IP traffic is coming,
Yes, definitely. Why not?
request is coming?
Yes. Your firewall can identify that. Yes.
Okay.
Okay. See. So 10.1.1.1, this is the IP on your this PC. Oh, let me give the name of the PC as well. Let me make it PC1. Okay. Let's suppose this is PC1. This is PC2. This is PC3. This is PC4. And this is your switch. Let's suppose this is your switch one. Okay. The switch will be there inside your company or somewhere if you are going. And this switch is the purpose of switch is to connecting multiple end hosts with each other. Okay. And that is actually doing here as well. The same thing it is performing, isn't it? See, there are so many PCs, 4 PCs, and they are connected with each other using this switch. All right. Now let
Okay.
me give IP. How I'll be giving IP? See, everyone need to do this, guys. And this task I'll be giving you today. And tomorrow, once you are coming now, I'll be just seeing if you are able to do or not. See, PC1 will have 10.1.1.1. And how you'll be assigning IP? Go here on fast Ethernet 0 and give here IP. Here 10.1.1.1 and subnet mask. Once you will press your tab button in your keyboard, it automatically will grab the subnet mask. See, 255 means /8. Understanding that? And I'm finishing it now. Go on PC2, config, fast Ethernet. Here I'm giving 10.1.1.2. That's it. Come to your PC3, config, fast Ethernet 0, 10.1.1.3. Able to see everyone? Easy?
Yes. Yes.
So just go with me. No need to rush. You will be getting all the concept very easily. So let me also give the name of this PC4 actually. Isn't it? This is PC4. Na? Here, this is PC3. Let me give the name as PC3. Here I am changing the display name. Even it is not showing anywhere. But if you, let's suppose later on you want to see the device name, then it will be showing PC1. Okay. Yes. Good. Yeah. Simple. You provided IP. Now tell me how many addresses now your this device has. Any guess? See this particular pop-up that is available on your screen. Now see, fast Ethernet 0 has how many addresses? IP address part, it has 10.1.1/8, right? See,
Yes. So it has 9 address, no?
where is 9?
IP address that you are saying, no?
Able to see this one? Let me take a snip if this is possible. Not possible. See, are you guys able to see this particular pop-up on the screen? Device
Yes,
name
yes,
PC1. Yeah.
yes,
Go to the port. Inside the port, what is there? Fast Ethernet 0. Able to see?
yes,
Little bit right. Link is up. IP address is 10.1.1/8. Good. One address. Go little
yes,
bit more far, and MAC address section has 00D0 9780 Able to see?
yes, yes, yes.
So it has how many addresses now? Technically, on the fast Ethernet 0, it has two addresses.
Mm.
Agree? Yeah.
2
And
MAC addresses.
so this is the real addresses that you'll be seeing in modern day technology actually. If
Okay,
you
2
are
2 MAC address, no?
two
Or
MAC
one,
addresses you are seeing on the same interface, how many addresses you are able to see?
two MAC addresses, no?
Where is two? On the another one is on Bluetooth, man. See?
Yes, yes, yes. So fast Ethernet, 1 MAC address.
Yes. So technically, if you are talking about this interface that is connected with the switch, it has how many addresses? One there was
1.
already, it was there by default, correct?
Uh,
And another one you put there. This IP we gave, na?
yes,
So how many addresses are there actually now? Two.
2.
Good. Now, in the OSI model, these cables that you are connecting here, na? See, this cable connecting with switch. These cables actually work at physical layer. What layer, guys? Physical layer, guys. Good. Here your cabling works. Okay.
Okay.
Cabling, if that will be wired, either that will be wireless. What does that mean? Let's suppose you are coming here with wireless also will work.
Okay.
Let's suppose you connected with some AP. AP, you guys get it, right? I'm talking about, let's suppose this PC. It has something. Let me take one AP that I'm getting here. Lab PC. Let me connect it. This is up. Just wait. Huh? I'm going wirelessly here. I think it should be connected now. Just a moment. PC wireless. Let me connect. Nothing is there. Actually, I'm just making it little bit realistic, guys. Okay, just be with me.
Yes, yes, yes.
Settings. Physical one. Attributes. It is not giving me option to do so. This is lightweight, na? Okay. Let me take another type of modem. Actually, just wait. Might be
What
AP.
is modem?
Simple modem, I'm saying. Modem, home routers, like you
Okay.
have seen, na? Modem, that is only there. Early days, if you guys have seen, there was coming one modem having some SIM port there, and you can connect some SIM with that particular modem, and later you can connect the modem with your laptop or device. You can connect with internet. Anyone here who have seen that? No?
No.
Yes?
No.
Now see, let me connect this one with new option. I'm removing this from here. This can be a case. See, you have one modem and these devices are wirelessly connected. Able to see? This is your laptop. Getting it?
Yes.
So now you have different devices, no? They are connected. Few are connected using wire and few are connected using wireless. Few means only one device is there. Let me make another laptop in the picture. Uh, Another laptop I'm bringing in the topology. And I'll be going here. Actually, it needs some additional port for that. Na? That's why this port you'll need to take. As you'll be bringing it up, it will automatically be connected. Two devices are connected using wireless. And one device is, all other devices are connecting using wired. And let me go here and give IP actually. So I will go here inside config. And wireless one I'll be giving IP, isn't it? See, I am giving here, let's suppose 10.1.1.5. Is that good, guys? 10.1.1.5 I've given. On this laptop, I'm giving here 10.1.1.6. Let's suppose I'm trying to give 5. It is not taking like it is working then. Wow. Good. Everyone is with me. Hello.
Yes, yes.
Very simple, guys. 10.1.1.5/8. This is laptop 1 IP. And similar type thing I'm going to do here. And this is laptop 2 IP and it has 10.1.1.6. Interesting, isn't it? Tell me. So these cables work at what layer? Wired or wireless, whatever medium you are using to connect with the network. This comes at your physical layer of OSI model. I hope so it is understood by everyone. Tell me if you are not understand. Very much realistic approach I am taking here, guys, so that you can relate well. Is that fine? Hello?
Yes, yes.
Okay. I'm just hearing from Harshvardhan only. Yes, Akram, you're getting it. No response at all, no issue. Now let's move little bit ahead. We talked about MAC address, right? So MAC address actually works at what layer?
System level.
Data link layer actually, yeah? See, oops, like that. At data link layer, your MAC addresses actually work. Is that fine? Going one step ahead. See, cabling works at physical layer. Your MAC address works at data link layer. And you gave one IP to all your devices, isn't it?
Okay. That is IP layer.
That
Network
is your,
layer.
yeah, exactly. That is your network layer. Here, your IP address works. Understood? Good. So far, so
Okay.
right?
How does that IPv6 work?
Yeah, we'll be coming, Harshvardhan, on that part
Okay.
also.
Okay.
Later on, we'll be coming. That is good.
Huh?
That's good, right? We'll be coming later on
Yes,
IPv6.
yes, yes.
For everything will be understood.
Okay. Okay.
But we'll be starting from the scratch, and we already started actually. Without rush, I'm explaining you all the concept.
Yes, yes.
No rush for me, and I will expect not from you all.
Correct.
Just
Correct.
stay here and see everything. You're not going to get anything that will be empty. No, everything will be there with the purpose, and IPv6 also is one of them. And now, so far, you understood these three layers you got, right? So cabling works at physical layer. MAC addresses are there that you just seen. It works at database layer, and IP addresses works at network layer. What about transport layer, guys? Any guess? So let me tell you. Let's suppose now you have all the things ready here, isn't it? Yeah. Now you are going inside your PC1 desktop and opening this web browser, and you are pinging 10.1.1.2. Let's see what it is giving. What it is saying? It is saying server reset connection. Just one moment. Let me take here one server. So it will give good clarity actually. Wait, I am taking a server and doing like this. This is server. I'm also going and providing IP. This is server 1 and IP I'm giving it 10.1.1.10/8. So once the class will be over, na Harshvardhan, you try
Hmm.
to do this particular thing that I'm doing here. You make this topology, give just connect them, okay?
Okay.
And then tomorrow, once you are coming, then make sure this part is done. 10.1.1.10.
I don't know how to use this interface and install this interface.
One sec. I'll be telling you. Wait.
Okay. Okay.
I provided IP 10.1.1.10 here on this server. And I will be providing in the same way. Go to fast Ethernet 0 and provide. That is good. Now okay. Now I can go inside my server and inside services. Here is so many things. HTTP. Let's suppose I'm enabling HTTP. Already enabled actually. This is on, this is on, both are on. Now let me click on this PC and let me go on browser and 10.1.1.10 this time. Able to see this web page? It is saying
Yes.
Cisco Packet Tracer. Welcome to Cisco Packet Tracer, opening doors to new opportunities, mind wide open. A small page, hello world by copyrights. This is about like this is a page. And how you got this page? By going in your web browser of this PC1 and by putting this particular IP. And whose IP is this? Your server IP. Whose server? HTTP server, web server actually. Is that fine? So far, so good.
Yes. Yes.
Now, question is, once you are going to your browser and typing this type thing, then what happens? It has so many things. See, HTTP is there working, right? Now tell me, web browser is what? Is that any application?
Web browser.
Browser is an application, right?
Yes, browser is application.
That is installed inside your native OS, native operating system, correct?
Correct. Correct.
Okay. Now, this particular browser, that is application, it has few things that you are using. Let's suppose who is helping you to show all the things on your screen. So so answer is HTTP, right? Who is working in backend to show you all these pages? That is HTTP. What does that mean? That means once you want to see some web page inside your browser, HTTPS is their protocol working in backend to help you to see that. Hypertext transfer protocol, correct? So let me take one another example. Let's suppose I'm going and opening Google, or let's suppose I'm opening Amazon.in. So who is working in backend to show me this page? Answer is HTTPS. Correct? So HTTPS is doing all these things done for us. That's why we are able to see this part on the screen. Is that good understanding?
Yes.
Now let's move here little bit. In application layer, your HTTP works. Is that good? Where it works? At application layer. Very top level overview. If you're not getting it right now, let's suppose you'll be getting once one, two, three classes will be done on the same part. I'll be giving you different aspect of the same OSI model. Don't worry. Not only one aspect. Correct? Yeah. So HTTP works at what layer? Application layer. Why application layer? because this is working on your application, your your application that is installed in your system, in your device, and that is actually helping you to see all the contents over your screen inside the application, isn't it? So actually application layer is a layer that is there available inside your SI model, that is working like a medium, you can say interface, or you can say interface between your application and network. Is that good?
Okay.
So whatever protocol is working there, that will be working at application layer. So far we have seen cabling works at physical layer, MAC address works at data link layer, IP addresses works at network layer, and these protocols who are the helper, or you can say who is providing you interface so that you can see the complete web page on the screen. These protocols actually works at what layer? Application layer. Understood?
Okay.
And this particular thing, let me show you again on the same part. This particular thing, how the things are represented, how this font will be used. Okay. How the what at what place what button will be showing. All those part, like the presentation part, representation part comes under your presentation layer here. Getting it? All the presentation type things.
Means UI part you are saying.
Yes.
Okay.
What about session? Once you started doing communication, once I opened this website, so there was a session got established, like session started, correct? And all those sessions that is getting, let's suppose I'm opening another Amazon.in. I'm opening another Amazon.in. So there are different sessions, one, two, three, correct? With the same website. So who
Yes.
is managing all these sessions separately and managing, like creating session, managing session, and after that terminating the session, that comes under your session layer. Is that good?
Yes. Yes.
Creating. Now, this is the very practical way of understanding the SI model actually. Okay. It is there for creating, managing, and terminating the sessions. Good. Okay.
Yes.
What about transport layer, guys? Very good thing, actually. Now, it depends on the what, like just understand it like what type of service you are accessing right now. Right now, we are doing this meeting,
Hmm.
correct?
Hmm.
This meeting will be using either TCP or UDP. And what does that mean? Let me tell you. So, TCP means this is reliable and takes guaranteed delivery. You're getting it? Guarantee delivery. Reliable and takes guarantee of delivery. UDP is considered as non-reliable and does not have any guarantee of delivery. Okay. So these two type of things we actually see in our daily world. What does that mean? That means, let's suppose you are talking using your mobile phone. Just relate with that. Have you guys ever seen some faced any network outage or network breaking? And once there is any network outage or something like that happens, you are not going to get the complete voice. It what happens sometimes, you are saying your another caller, hey, your voice is breaking, you're not audible. This everyone faced, correct? Yes or no?
Correct. Correct. Correct.
So this type of communication, that is real time, even you can say real time communication, actually uses UDP in backend to the transmission. Okay.
Okay.
Let's suppose you are sending an email to your friend. Okay. So if you are sending an email to your friend, so in that case, you need that email should be delivered to your friend's email box 100%, and all the content should be shown there, isn't it? That
Okay.
type of communication we use TCP. Like our technology uses what in backend? That is TCP. So once the communication requirement is reliable delivery and 100% guaranteed delivery, then in backend, what technology is being used, guys? That is TCP. Is that making sense?
Yes.
And once there is reliability or 100% delivery is not the concern, then in the backend, what technology is being used? That is called UDP. I hope it's clear a little bit. Yes, no? Tell
Yes,
me.
but why we use UDP when there is a TCP?
Yeah, exactly. Good question. So this is a question that is very, very much relatable. Let me tell you the answer. So reason is UDP is faster than TCP actually. Okay? UDP is faster than TCP. TCP takes guarantee, but it is not as much faster as your UDP is. Let's suppose you are streaming some online cricket match. Getting it?
Yes.
So what do you need? You need faster speed, or you are okay if the reliability is there, even you are getting the ball by ball show little bit later with delayed as well. What do
No,
you
no.
expect?
Faster.
Faster, na? So because you need faster, then that's why you will be using UDP, because UDP will provide you faster delivery. Is that
Okay.
good?
Okay.
Now it comes to the email sending, correct? you
Yes.
you need that faster as well, but not real time. Even let's
Yes.
suppose I'm sending you some letter, then you are not going to read it live, isn't it? You'll be
Correct. Correct.
getting that, then you'll be opening that, because this is the big letter. You'll be opening and reading line by line. Then you'll be, let's suppose you got some reply, then you'll be replying back, and the sender will get back one reply, isn't it? Relatable, right?
Yes. Yes.
So TCP and UDP is clear now.
Yes. Correct.
Yeah.
Clear.
So TCP and UDP actually works at what layer? At the transport layer. So this is the very, these are all the layers are actually, I haven't shown you any example that is connecting all the layers, right? So far. So let me show you actually all those things at one place, like where all the layers are involved at one place. Okay. So, so far any question, please ask. So I'll be moving ahead.
No. So we can also basically send orderly traffic from UDP or TCP. It's up to us. Correct.
It's to the service that you are using at application layer.
Okay. So fixed services are there. They're like email services. Then you we can not use UDP. Correct.
So this depend on the technology maker or the service maker. Let's suppose you are application developer. Okay, just relate like that. Then you'll be getting the complete answer. Let's suppose you are application developer. You made an application. And what is the purpose of that application? That purpose of application is to helping all the people to watch the news videos. Getting it? And you have news videos that will be coming live. You are able to relate. Yes. So if
Yes.
you are making any application that provides services as live streaming on videos, crickets, all those things, live streaming, I'm saying. So now tell me what service you will use at what technology you will be use at transport layer, TCP or UDP?
Okay. That's a UDP, but so it depends on the app maker.
Definitely correct. You got it. Right? Who is working at application part will be deciding what type of service that application will be providing to the public, okay, to the users. And accordingly, the TCP and UDP will be decided by the application maker. Okay.
Okay. So
Yeah,
they will provide us which port to open, which port to close.
exactly. You got it. Like also the port. Port is really very much significant thing there.
Okay.
It has more significance actually. Why? Because there are thousands of services working right on internet. So which service will be working at which port, that is actually distinguishing all the services there. Okay, that will be talking little bit ahead once we'll be moving.
Okay.
Getting it? Yeah.
But same port can't have both the technology TCP and UDP, correct?
Same port can have same the technology.
Okay. Okay.
Like TCP and UTP both can work on the same port as well. No issue.
Okay. Okay.
Okay, there is not any such case. I hope you are getting it completely, isn't it,
Yes. No. No. No.
Harshwin?
Now I understand.
Okay, that is really good. That is my agenda also here, so you guys understand. Okay.
Yes.
Yeah.
Yes.
So let me help you to get all these things here, guys. Okay. So just wait. I am going to show you complete picture in one image. Let me first of all relate this with your TCP IP. So there is very famous and actually real time used model also available, that is called as TCP IP model. Able to see? So TCP IP model doesn't have all these 7 layers. However, it has 5 layers. Somewhere you will be seeing the 4 layers, somewhere you can see the 5 layers. But what I use in my demonstration is 5 layer. Okay, let me show you. How many layers, guys? 5. So this is not available inside this. They removed this. Removed means layer 7, 6, and 5. They are saying this, they all belong to application layer only. Able to relate with me?
Yes.
They are saying these three will become only one layer, that is layer 5, that is application. That's it. And they are little bit changing the name. Network layer, they are saying this is internet layer, and rest part is same. Making sense? You're understanding with me?
Yes. Yes.
So this is your TCP IP model. And this is a real model that we use in the industry. So OSI model was there for what? For just a blueprint reference, correct? Even in the companies, your network engineer buddy is going to talk with you with the OSI language. Hey, it works at OSI model this, OSI layer this, OSI layer that. Not TCP IP layer he'll be talking. Believe
Okay.
me, no one is going to ask you, hey, this works at TCP layer 3. No, everyone will talk you, this works at OSI layer 3, OSI layer 5. Why? Because that is really very much famous in the industry. Okay. People use OSI as reference. TCP IP is the real practical model that is used inside our networking actually. In backend, TCP IP is used. But for reference, OSI model is there. Okay.
Okay.
Now, I'm going to show you using this TCP IP model. And in the layer 5, all these three are included here. I hope so. So far, so good.
Yes. Yes.
Okay. Let me show you now here. See. I am going inside my PC and opening a browser. See my screen, web browser I click. Now I am going to run a service that is available on my server, that is 10.11.10. I want to open this server's web page actually. And I want to show you something very interesting. I am opening simulation. See here, right side. Able to see where my cursor is right now? Able to see my cursor?
Yes. Yes. Simulation.
I am clicking here. Now I am going here and opening all the things and I am clicking on go. Now let me show you this one. This packet you are able to see. What is the type of this packet?
Data.
Again, see. Type is TCP. Able to see?
Yes, type is TCP. Okay.
Now let me tell you really very interesting part. So once you opened this browser, oops, not this, man. Wait a moment. Oops. You opened this browser, able to see this HTTP.
Yes, yes.
So HTTP is you can say it is a service, okay, or protocol even you also can say. This service works at layer 7 of OSI model, and it is binded with your TCP at transport layer. Is that fine now? Like HTTP use TCP in backend as
Okay.
technology.
But your IP is 10 and here is IP is 1.
Where? No, I'm pinging this server one, na. I'm
Okay.
trying to. This is
Okay.
the IP of your server actually
Okay.
that I'm
So
putting.
target server we will open.
Exactly. To yeah, you're right. So to show you this demonstration, I'm using this web browser where I want to open some web page that is here inside your server.
Okay.
This is just like this. I'm opening, let's suppose Amazon.com or some other things. So I'm not opening directly them. To make it simple, I'm opening inside our lab only. Okay,
Okay. Okay.
good.
Okay. Okay.
See, you are really saying HTTP. So at layer 7, what is working? HTTP. Okay.
Okay.
HTTP use which technology to do the communication? TCP. At layer 4, it is using TCP. Understanding that or not? Tell me.
Yes, yes. Understanding.
Good. Now, it is using TCP there. Now, what will happen? Next, it will come to the network layer as well, isn't it? It will come to the network layer, internet layer as well. Here, what works? IP addresses, isn't it? So, source IP will be what? 10.1.1.1. Who is the sender? This one is the sender, right? What is the
Dot
IP it
1.
has? 10.1.1.1. Okay.
Huh. Huh. Huh.
And who is the destination? 10.1.1.10 server, right? See where it is going? It is going to 10.1.1.10. So the destination IP will be 10.1.1.10. Is that making sense?
Yes, yes.
Good. So now I hope you are able to relate. At application layer, HTTP is used. At layer 4, TCP is used, right? At layer
Yes.
3, it is using IP. And now let's go to your MAC address level, like that is data link layer. Now see what it will use. Even I can show you. Go here and see the, mm, not here. Inside this even you can able to see. Just see it. Layer 7, it is using HTTP. Okay.
Okay.
Layer 4, it is using, able to see TCP, right? Not source port and destination port I'm talking right now. I'm just giving you one top level. At layer 3, it is using source IP 10.1.1.1, destination IP 10.1.1.10. At layer 2, it is using source MAC and destination MAC. Able to see?
Okay.
And after that, at layer 1, it is using cable. This cable it is using to send the traffic out. Is
Okay.
this able to relate? Are you able to relate with the all the OSI layers? Now,
Yes, yes.
very simple, isn't it? Tell me.
Yes.
Yeah, exactly. But once you don't know all these things, this is very difficult for all the engineers in the industry actually. They are being asked in the interviews and they are getting failed every time. Why? Because they never use this particular packet tracer to see this. Okay.
Okay.
So, how communication actually happens, that I'm telling you. Just wait. Once I'll be sending this to your switch, switch will do what? Whatever switch is doing, let it do. We are going ahead. Now see. Wait, yeah. What is this? This is HTTP, correct?
Where is?
Here, this which color? Brinjal color is that? What color is that?
Yes, yes. Purple.
Purple, sorry. I'm very bad in coloring, man. I don't know.
How does this effect came?
I didn't do anything. I just opened the browser of PC1 and tried to ping that 10.1.1.10. That's it. And everything
Okay.
was happening by default. I'll be telling you all the steps, but just I want whatever I wanted to show you, that I'm showing here only.
Okay. Okay.
Okay. Layer 7, what is working? See, HTTP. Layer 4, what is working? Your TCP. And TCP source port is it is using, and destination port also it is using. Now, this is very important to understand, Harshvardhan. See, at layer 7, layer 5 in our case, actually, in a TCP IP, it is using HTTP. Able to see? Yeah.
Yes. Yes.
At layer 4, it is using TCP source port. Source port will belong to whom? This PC1 is using some random source port. Not the exact, any random source port it is taking. Is that fine?
Mm,
Why port it is using? This is the question, right? It can be a question. Why it is using port?
port to access particular service.
Exactly. Let's talk about HTTP.
Hmm.
Let's suppose if PC1 wants to talk with server and that is related to HTTP talk. Then this PC1 will send that request to the port number 80. Why? Because HTTP service works at port number 80 actually. Understanding?
Okay.
So if
Okay.
this server will get any request that is HTTP request and the port number is 80, then it will automatically identify, oh, okay, let me see. This person wants to access my HTTP service. Why? Because this is requesting me at port number 80. Getting it? What does that
Yes.
mean? That means once you are application developer or you are technology maker, or let's suppose you are owner of, or you can say you are founder of some protocol. So once you will be making protocol, you will be also defining that the port number, this protocol will use which port number, this protocol will use TCP or UDP at transport layer or what, like that. That part you will be doing. Is that fine?
Yes.
Yeah. So once HTTP was made, it was supposed to use port number 80. So if any request is coming for port number 80, it means that is for HTTP. Is that fine?
Yes. Yes.
Very simple, isn't it? Is this hard to understand or simple? Tell me.
Understanding
Okay.
slowly.
Slowly. Good. No issue. No issue. First time, na? First
Yes.
time it is not very easy. But once you will keep seeing the same thing, it will make the things easy actually. Don't worry. That is on us actually at all. Okay. So because this PC1 is trying to access service that is HTTP, that is server service, that it wants to access the web page on server 1. So it is requesting that for port number 80. To whom it is requesting? To 10.1.1.10. It is saying to 10.1.1.10, hey, listen, I want to access your web service. Is that good now? And how it will say that? By sending that request to port number 80. See, what is the destination port? 80. And what it is using in its port, source port, it is taking some random port. Okay, this is client. Why? Because port is really required. Why port is required? Once this server will be replying back, so server will use source port as 80 because server is replying back. Okay. And to whom it will send them? To the requester. And who is the requester? This 1031. So once the reply will come back from server, it will be totally reversed and flipped, you can say. Is that making sense? Hello.
Yes. Yes.
So at TCP, it is using TCP source port 1031, destination port 80. At layer 3, it is using source IP as 10111 and destination IP as 101110. Okay. And here is the MAC address. MAC address is of fast Ethernet 0 interface here. And destination MAC is for F0 interface of your server. This interface. I can even show you. Wait. Go to config, fast Ethernet 0. Able to see this MAC address? EC3A. Okay. Now go and see here. EC3A matching destination MAC address. Simple, na? And this
What
0C.
what is
Mhm.
like header and what is the composition of this?
Will be coming on that. That will be more high level then.
Okay, okay.
Will be coming on that. Just understand. Is this understood?
Yes, so
Mhm.
layer 2 Ethernet to header.
No, no. This one, man. Is this MAC address is belong to PC1 and this one is belong to your server one because the
Okay,
communication is between both of them, na?
okay,
Okay.
okay,
This is not only one OSI class. Don't worry. I'll be
okay.
giving you little bit expanded minor once. Like tomorrow you'll be
Yes,
coming.
yes.
That will be little bit more. Then next class you'll be coming. That will be little bit more.
Okay, okay,
And 3 4 classes will be doing and you will be getting it 100%. Don't worry. Okay.
okay,
Every part will be understood. Just understand this right now. Okay. Mhm.
okay.
So at layer 7 it is using HTTP. Then at layer 4 it is using TCP source port this and destination port 80. TCP source port will source everything belong to PC1. Okay. And destination is belong to server 1. Getting it? And
Yes,
see layer 1 your cable, layer 2 your MAC address, layer 3 your IP address, and layer 4 your TCP, and layer 7 your HTTP. Is that good now? Layer 5 even you can say. No issue. Simple?
yes,
Yes, no? Tell me. Now let it
yes.
send. It is been sent. See, your server 1 receives that. Where it receives? It receives here only. It receives the frame. Server 1 receives the frame on fast Ethernet 0 interface here. Then it checks what is the MAC address. It comes to know the frame's destination MAC address matches the receiving.
Where is receiving?
So sorry, I got disconnected due to internet issue. Okay.
Yes, yes.
Might be you are asking me, but I was not responding, right? We were here, right? See, screen is through.
Yes.
See, it receives that thing on port number if fast Ethernet 0. And at what layer it receives the request? Layer 1. Correct? Then it jumped
Yes.
to where? It jumped to the layer 2. It matches its MAC address. Okay, that is good. And after that, it checks the request for whom. The destination IP is for 10.1.1.10. It is for him. And see, for which port? The service is port number 80. It wants. After that, what it will do? See? So actually, this is only working the TCP IP. Just wait. Now this one is the HTTP. And which one is that? Okay, let me come back with this. Wait. Now see here. This is the real picture that I just need to show you. See, that HTTP request your server got on the fast Ethernet 0. Check the MAC address, IP address, then port number, and see here at the layer 7. It is saying the server receives a HTTP request. Now see the server sends back a HTTP reply to the client. PC1 asks for what? HTTP. Like it asks for your web page. Show me your web page. What was the request? Show me your web
Web
page. This
page.
was the request. Okay. Now your server got that. Now it is making reply. See, isn't it really changed now? See, source port is now become 80. Earlier it was for the destination 80. Now this is the source port. See,
Yes.
destination is 1031. Just
Yes.
flipped. IP is changed also. MAC address is also changed. And everything is changed and is sending it back. Getting it?
Yes.
Now, once it will reach to your PC1, might be your PC1 will come up with the what? It will be seeing this particular page. Page is opened. See, you got the backend part and you understood the OSI model. Tell me if you're not understanding so far.
No, understanding.
Good. At least top level view you are getting, right?
Yes. Yes.
Okay. So since this was TCP communication, so I told you if you remember, TCP we call as reliable, right? Guaranteed delivery. Correct. So once
Yes.
we call it this is TCP and this is reliable, what does that mean? That means for reliability, it will take few steps or not? Tell me. How you'll be ensuring this is reliable, this is trustworthy, this is guaranteed delivery? How? You'll be doing few steps, isn't it?
Yes.
How your let's suppose you're ordering something on Amazon. How Amazon takes guarantee for 100% delivery? Tell me. They have some mechanism, correct? Isn't it? Let's suppose people comes to you and they ask you, hey, tell one OTP you got. Just tell me that OTP. You guys remember? Once you are taking any delivery,
Yes. 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 Yes.
the
Exchange.
yeah,
Handshake. Handshake. Handshake.
yeah, that is handshake. Actually, definitely, in the TCP there is handshake, but in the normal scenario, in general, what happens?
Oh.
Delivery agent ask you OTP, isn't it?
Yes. Yes.
Or at
Okay.
least the delivery agent will call you in front of you, and if you are picking up the calls, they'll be asking, what's your name? You'll be telling, hey, my name is Amit. Okay, okay, good, good. It means this was for you, yeah? What you order, tell me. Then you'll be saying, I ordered this thing. Okay, good. Take it. So, like checking the reliability, yeah? If the same package that is destined to the real person is delivered or not, correct? Agree?
Yes.
But this is not in the technology, na? In technology, you will be using some other mechanism. And TCP uses three-way handshake for that. Correct. So once TCP is actually in the game, in the picture, what TCP does, TCP before doing any communication, it makes sure if the connection is built or not. Like it is going to do three-way handshake. And once the three-way handshake is done, then it means your connection is established with the whom? With client and server. Is that good? So who is client in our case and who is the server in our case? Tell me. In our case. Client means who is requesting for a service. Who is requesting for a service? Tell me. PC1. PC1 is opening the URL and trying to get this web page, isn't it? Who typed it and clicked on go? You, right? And which PC you are using? PC1. So PC1 is here what? Client. Isn't it? Tell me if you are not getting it. Who is requesting this service? PC1.
PC1 is requesting the service, correct?
So who is requesting will become the client. That's it. Okay.
Okay. Okay.
And to whom it is requesting?
Server 10.
10.1.1.10, correct?
Huh.
And so 10.1.1.10 will become here what? Server, correct?
Yes.
So the request, who is the requester will become client, and who is the provider of that requester's response will become server. Is that simple?
Yes. Simple.
Good. Now I'm asking you, Harshvardhan, send me one file on my WhatsApp.
Okay.
Okay. Now tell me in this scenario, who is server, who is client?
I am client in your server.
I am asking you, give me that file.
You are asking me. So
Yes.
you are asking me, you are sending request to me. And
Yes.
I am sending you file, so I am the server.
Exactly. Now you got it. So requester is what? Client,
Requester is client.
and responder is
Server.
simple or not simple? Tell me.
Yes,
Very
yes.
simple. Yeah. So who is requesting for a service will become client, and who is fulfilling the requirement, like replying back for that particular request was made by the client is known as server. Okay. Good. It's very simple. Isn't it, Akram? Tell me.
Yes, sir.
Simple, right? So far, any question, Akram?
No, sir. All good.
Okay, that's fine. Then you're understanding. Good. Now, point is really good. So, this PC1 is what? Client, and this server one is the server. Now, because the TCP is used for this communication, so TCP makes sure if the legitimate server and client is talking with each other or not. It's very simple. So before doing this communication and showing this web page on your screen, if you have seen, there was so many things were happening in backend, right? This packet was booming, right? If you see, let me go, let you back little bit. You have seen this one, na? Let me. TCP you have seen first time, isn't it? Once the request was made here, what was seen here first? This TCP message, TCP packet, right?
Hmm.
Isn't it?
Yes.
And what it is this? Let me show you actually. It is saying HTTP client makes a connection to the server. What does that mean? Connection means before requesting anything from server, your client will start making connection. And for the connection, what this PC1 will do, let me tell you really well. See, guys. So first it will send a SYN message to your server. What it will send? SYN. You guys are with me?
Yes.
Okay. So this is the SYN message that was sent by your client. Okay. Now your server will reply back for that SYN, that is known as SYN plus ACK. Okay. Your server will reply what? Sin plus egg. So how many packets so far? One, two. Two things. Like two-time handshake happened, isn't it? Now, once your PC1 will get, I am seeing this SYN plus egg from my server, like my server is in sync and also acknowledging back for my SYN request. Now, it will send what? It will send final egg. Is that good? Now, tell me how many times the things happened so far? SYN, SYN plus egg, and then egg. Is that good? So, this is known as three-way handshake, guys. Okay. You guys are getting it or not? Tell me.
Getting.
So once the TCP will ensure the three-way handshake is done, then it will send the HTTP request. So the request I was showing you so far, that was later thing, not the first thing. First, your client and server will make sure they are connection oriented. They are connected or not. So first, what will happen? TCP three-way handshake will happen to see the reliability. Is that good?
Yes.
I hope it's pretty much clear to everyone here in this particular class.
Yes.
Like Akram and Harshvardhan, only two people are here. But yeah, easy to understand or not? Tell me. Any question or anywhere you are getting confused? Tell me right now.
No question.
That is good then. Okay. Yeah. So let me go here on 10115. I'm just removing this real time. Okay. Making it real time. Wait. And I'm going on my laptop, this laptop, and trying to do the same thing. I'm going from here, let it open. I'm making it simulator, not simulator. First time, let me ping it. Uh, Desktop 10 1110. Let me see. Server is occupied. Why it's not giving me reply then? IP config. Oh, I don't have IP. Sorry. Let me give IP, man. Okay. It doesn't take any IP, really. Oh, so it doesn't. No, wait. I'm not going from here. Wait. It should be IP, but why it's not going? IP config. Yeah, it has IP 10115. Okay. Ping 10115 first. It's pinging. That is good. 10 1110. Oh, it's not going. Okay. Why it's not going? Wait, huh? Guys, let me see something. Why it's not going? Then, oh, here is the issue actually. Oh, will not use that. I just shown, I've shown that. That is fine. I'm going on another PC, guys. Okay, that is the later part. I'll be showing you later on. Just I'm going here. I'm trying to ping here 10 1 1 10. Wait, it is open, right? Good. That is really fantastic. Now I'm going and making it simulator mode. And again, I'm going on the web browser and wait. See what will be happening. Clicked on go. Tell me what packet is this? TCP. Why TCP? Harshvardhan, tell me. Because HTTP use TCP, right? So this is now TCP's job to make sure if the connection is oriented or not, isn't it? Yeah. Am I audible? Yes, yes, I think.
Hello, hello.
Yes.
I was speaking on mute.
Oh, no issue.
Okay.
So first it will make sure two connections should be established, yeah, connection oriented communication, isn't it? So
Yes, yes.
first it will send TCP. Let's open that and see what is this. You go here if for example, oh, okay, just make it bigger. Not showing so many things, but uh, actually it is not giving any sense. Now if you want to read, na, read it completely. You will be getting it. See, here here HTTP connection is in the place, but before that,
Sir, can I continue from tomorrow? Like my mind is now uh, not able to grab more.
no issue, man. Sure. So let me save it, okay?
Okay,
Let me
okay.
save it. Save a file. Let me see. This was OSI model, na?
Hmm.
So desktop is fine, I think. OSI model. Okay, Harshvardhan. Okay, Akram. Is that fine for today? We can close here only. Tell me.
Yeah, sure, sir.
I think this was overloaded one.
Yes, yes.
Isn't it? So,
Okay, sir.
so far you guys understood, na? This is the,
Yes,
yeah. So
yes.
make sure you are doing the good revision, okay?
Okay,
Then,
okay.
then come up again tomorrow. So if you will be doing the revision, na, believe me, guys, I am that person who is going to help you to understand complete CCNA.
Okay, sir.
Okay.
Oh, okay.
Even after completing the CCNA, whatever company you are going for interview, na, that interviewer will be happy. Why? You'll be able to answer all the questions. Okay.
Okay,
Like
sir.
I'll be not taking guarantee that if you will not be reading, then I can't take. But if you are with me, you are following the instructions, believe me, you are going to rock. Okay.
Okay, okay.
Okay, guys. So we'll see you guys tomorrow at 9 a.m.
Okay,
Bye.
sir. Thank you. Bye.
Bye. Bye. Take care, guys. Bye.
Bye.
Bye. Bye, Akram.
Bye, sir.
Bye, Sachin sir. How can remove that?